For this problem, we're going to solve a rational equation. Now, in the first term, 2x over the quantity x squared plus 6x plus 8, we need to factor this denominator. Now keep in mind what we're trying to do. We're trying to solve for x, and it would help us a lot if we could clear these fractions in the denominator. So in order to clear the fractions, we first want to factor the first denominator. When we do that, we have the 2x in the numerator over, this becomes x plus 4 times x plus 2 in the denominator, plus 2 over x plus 2 is equal to, on the right side, x over x plus 4. Now we want to multiply both sides of this equation through by what would be the least common multiple of all the denominators, and that will be the quantity x plus 4 times x plus 2, and that's going to allow us to clear the fractions. But before we multiply through by that, let's stop for just a minute and take note of our restricted values. Remember, anytime we have a rational equation, we have some expressions in the denominator with x, we want to exclude any values that could make the denominator 0. Now notice, if I substituted in negative 2 for x, it would make this denominator right here 0. So we want to make sure that x cannot equal negative 2. Also, if we substitute in negative 4 for x, it would make this denominator 0. Therefore, x cannot equal negative 4. So those are the two restricted values. We want to keep that in mind in case we get one of those as a solution, we cannot use it. So we decided we're going to multiply both sides of this equation through by the quantity x plus 4 times x plus 2. So we have x plus 4 times x plus 2 on the left-hand side, and we'll do the same on the right-hand side. And let's write this out. We'll have x plus 4 times the quantity x plus 2 times 2x over x plus 4 times the quantity x plus 2. Plus, we need to distribute this x plus 4 times x plus 2 through the parentheses, and we'll have x plus 4 times x plus 2 times 2 over x plus 2. And on the right-hand side, we just have x times x plus 4 times x plus 2 over x plus 4. Now our fractions should clear. We can divide out any like factors, so we have x plus 4 and x plus 2, and our first term just becomes 2x. Plus, on the second term, notice x plus 2 cancels with this x plus 2 in the denominator, and we have x plus 4 times 2. I can write the 2 in front of the x plus 4 since multiplication is commutative. Equals, on the right-hand side, x plus 4 cancels with the x plus 4, and I have x times the quantity x plus 2. So now we have an equation that no longer contains fractions, and we're going to continue by solving this equation. So here's our equation. 2x plus 2 times the quantity x plus 4 equals x times the quantity x plus 2. And remember, just as a reminder, we decided in our first step that x could not be equal to negative 2 or negative 4. So let's distribute, and we have 2x plus 2x plus 8 is equal to x squared plus 2x. This is a quadratic equation now. Let's simplify the left-hand side by combining the like terms, and we have 4x plus 8 is equal to x squared plus 2x. Since my x squared term has a coefficient of positive 1, I'm going to leave it on the right-hand side and move these other two terms on the left-hand side over to the right-hand side. And I'll have 0 equals x squared. I have positive 2x on the right. When I subtract 4x, it becomes minus 2x. And then when I subtract the 8, I'll have minus 8. Now this will factor nicely. I'll have 0 equals, I'll set up my parentheses. Looks like x minus 4 times x plus 2 is the proper factorization. It's always a good idea, once you factor, to check to make sure that you factored it properly. So we've now set each of these factors equal to 0. If I set x minus 4 equal to 0, I'll get the solution x is equal to 4. Or if I set x plus 2 equal to 0, I'll get the solution that x is equal to negative 2. Now, before we state our solution set, let's notice what we have up here. X cannot be equal to negative 2 or negative 4. Therefore, when I got this solution, x is equal to negative 2, I have to cross it off because negative 2 would create a 0 in the original denominator. So x cannot be equal to negative 2. So therefore, my solution set is just 4.